A dentist knows from past records that 10% of customers arrive late for their appointment. A new manager believes there has been a change, so that's a change either up or down, in the proportion of customers who arrive late for their appointment. A random sample of 50 of the dentist's customers is taken. We want to, in part A, write down a null hypothesis corresponding to no change in the proportion of customers who will arrive late, an alternative hypothesis corresponding to the manager's belief. So our null hypothesis is just going to be P is 0.1, that's 10%. So that's the situation of no change. The alternative is just going to be P is not 0.1. It's just there's been a change. It doesn't say increased or decreased. And so that will be the appropriate alternative hypothesis. So let's move on to part B. Using a 5% level of significance, find the critical region for a two-tailed test of the null hypothesis in A. You should state the probability of rejection in each tail, which should be less than 0.025. So essentially what we have is a number line, and we're going to have a tail at each end. So we'll have value here and a value here that define the critical region. It's a 5% test, so there'll be 2.5% at each end, which is 0.025 as a decimal. And here we have the n equals 50 table. And we're looking at the 0.1 column because we're talking about 10%. Remember, the distribution here would be a binomial 50, 0.1. If we look at the value for 1, that's 0.0338. So that's too big. So we're only going to go for this value here. So we have a 0 at this end, and the probability there is 0.0052. So we want to do the same sort of thing at the other end, and we'll have to look at 1 minus the probability that x is less than or equal to each value as we go along. And when we get to 10, that would be clearly in, but 9 actually works here, because if we do 1 take away the probability x is less than or equal to 9, then that is going to be 0.0245, but that would make this value 10, because it's 1 take away the probability x is less than or equal to 9, so 9 is included in that, and so our values are going to be from 10 upwards. So our critical region is that x is equal to 0 and x is greater than or equal to 10. The actual significance is going to be 0.0052, add 0.0245, and that gives me 0.0297 or 2.97%. So that's part C. The manager observes that 15 of the 50 customers arrived late for their appointment. With reference to part B, comment on the manager's belief. So 15 is in the critical region. And that means that there is evidence to suggest the proportion has changed.